Now let's compute the geometric mean, and I write here print to make it separate from our first experiment. And y is 0. Our y is 7 0 values. So now I require a variable to return the value geometric mean. So I define it as a real GM value. Okay, geometric mean. So for x, here I write GM value equals 1. I cannot set it equal to 0 because it is based upon the products. So geometric mean calculation. So print asterisk geometric mean calculation. So here x has a length of 5. So I write here not for do I varies from 1 up to 5, and then simple geometric mean is equal to geometric means times x of, okay, this is and do. Then finally this value must be updated with the nth root, fifth root. There are 5 values, so it must be with the fifth root. So I will say it is equal to GM asterisk 1.0 divided by 5. This calculation is required, right? Or you can see it is 1 divided by GM. No. Okay, this is fine. Then we can print the values. Print GM of x is equal to GM. Okay, we have approach to that. Let's see whether we have a value which is close to the values of the central value of x or not. Compile. There is some error in the print statement. Yes, all compilers identify this problem. CLS. All the mean values are closer to the expected central value in the data. So 4.416. So you will find that some values in x are smaller than this value and some are larger than this value. So it's a true value. But if in the same program we require more than one calculation of geometric means of several vectors, so in that case we have to write this type of structure GM up to this level many times, right? For example, in this case we have a y vector set. If I require the geometric mean of y as well, so I have to repeat this structure, right? So it is always good to have a function for it or subroutine for it. So for making a subroutine, I will copy this part, and I write here a function. Function GM of x, and of course it requires the length of the vector. So here we have to define real x, integer I n, and real GM. Here I print the same algorithm. The 5 value should be generalized to n, and this 5 value should be generalized to n. And finally, I should write return GM and the end of function, end function GM, right? So it will take the x value and will return the geometric mean. In the main program, real GM has been defined, right? And I would like to call GM of x. So here I will call GM of x for 5 values, right? And for the other use, let's define some values in y, 7 values. For example, I say 3 times 1 and 4 times 2. 3 times 1 and 4 times 2. So it is going to have 7 values. So now I can calculate the geometric mean of y, right? So we have to say geometric mean y with 7 values. The function is generalized. Similarly, the subroutines will be generalized when you attempt the problems of vectors and matrices. So here we go. Critical stage. Swinging on Professor Levin's pendulum virtually. Wow, return GM and GMX. So let's look for the errors. Invalid return value and end function and function GM. Let's look for it. GM xn integers n. Do I varies from 1 up to n. GM return and GM. The reason for this error is that in another class, I am teaching some subject with Python. So in Python with the return, there is in its functions, there is no end function statement. There is just the return statement, and with the return, you have to provide the variable to be returned. So that's why it remained here. CLS. Again, I'm going to climb on Professor Levin's pendulum and like to swing in the hearts of my students. So, still not satisfied. There is warning, warning, warning. There is warning. Function GMXN. GM function x of I. Oh, the x is not a single thing. It's an array, right? It's an array. So, and for n it has been defined. Yes. Now, after removing this error, again confidently I'm going to climb on Levin's pendulum, and this time successful swing in the half cycle. The half cycle would be completed if the pendulum is going to return back, like the execution is successful. Here we go. Our program must return geometric means of 2 vectors. vtest.exe. Okay, so x vector with its 5 elements and y vector with 3 1s and 4 2s, right? And geometric mean calculations. So for y and for x. Programming works, functions work, right? And this function should be a part of our our CF library.for. We did that. We have been building that library. So let's copy this function, make our main program smaller, make the library bigger. In our library, there is first program graphs for students to do numerical integration. The library is going to be enhanced. So I write this function, calculation of geometric mean. This is the function. I'm trying to give you a feeling of writing the NAG library, which was done some 60 years ago. People were doing that type of practice. I'm in column 6. Oh, this is dangerous. 7th column. Look for the last one, 7th column. That's fine. So now you know you have a library of functions and you know how the functions work. Then you can compile the library CLS G77 ptest.for and CF library.for -o ptest.exe, right? Library and main program. I imagine that my students someday will be working with the NAG library in this fashion, or the IMSL library in this fashion. Context is not fine. vtest.for cf library.for vtest.for cf library. First defined here applications. It was not saved, therefore this type of error has emerged. Yes, the program was not saved. And now vtest.exe. It works. Programming works, and I'm still teaching.